the given integral belongs to trigonometric substitution case 3, where in the radicand you have a x squared minus constant square. If you take a look at the given integral, you might not see the integral, but take a look at the rational exponent, 3 over 2 power, right? So the 1/2, the yellow 2 in the denominator is a square root. So you square root first, and then you take the third power. So just consider the square root for ax squared minus a squared. So my a is equals to 1, and then you do a substitution by letting x equals to a times secant theta. Since we will be changing the dx to d theta, we have to differentiate both sides. So dx is equals to, the derivative of secant is secant times tangent d theta. And then this will replace the dx in the given integral. And then the top one, there is nothing to rewrite, but what about the square root of x squared minus 1? So that will be secant square, right? So secant square theta minus 1 secant square theta, that is equals to tangent square theta. So overall, that equals to tangent. And then we rewrite the integral. So we have integral 1 divided by the dx is secant theta times tangent theta d theta, right? This piece goes over here. And then don't just put the tangent in the denominator. You have to know that there is a third power, right? So there is a third power. So this is tangent third power theta, right? If you take a look at the square root, we only take care of the square root. We haven't taken care of the third power yet. So the third power stays there. And then we simplify that. So the 3 will be reduced by 1. So you have integral secant theta divided by tangent square theta d theta. And then this one, I know the next step is not going to be obvious. I am going to rewrite the secant and the tangent square. So the secant, that is 1 over cosine. And then the tangent is sine divided by cosine. And then d theta. And then if you take a look at the denominator, the cosine and the cosine square, so that is going to reduce the second power to the first power. So that means you are going to have 1 divided by sine square over cosine d theta. So that will flip the cosine to the top, and then the sine square stays on the bottom. Okay, let's do a u substitution. So the u substitution, let's do that in a different color. I am going to let u equals to sine theta. How come I don't attempt the cosine? Because the sine square theta, this is already a composition function. You have a sine inside a square root function. So that's why I let u be the sine. And then du is equals to cosine theta d theta. Can you let u be cosine? Yes, you can let u be cosine, but that is not going to work. Now, 1 divided by cosine du is equals to d theta. So this du is going to replace that d theta. And then we have a cosine of theta. The bottom is u squared. And then 1 divided by cosine du, the 2 cosine got cancelled. So 1 divided by u squared, that is u to the negative 2, right? And then when you integrate that, u to the negative 2 du, that is equals to u to the negative 1, and then there is negative in front of it. And then you are going to put the theta back, then you will end up with negative sine theta raised to negative 1. Okay, this one, I want you to take a look at this right now. Please do not do this. That is not equal to this. This one, okay, I should say this one is not the same as this one. The negative 1 is a power. If you look to the other one, sine negative 1 theta, that negative 1 is inverse. They are not the same. The inverse stands for inverse function. The inverse, the negative 1, is not an exponent, all right? So this sine theta raised to negative 1, that is equal to, you have negative 1 divided by sine theta. That's what the negative 1 for. And then you plus c. Of course, we are not done because the given integral is in x. We end up with a theta. So the next step requires right triangle trigonometry. So right triangle theta. And then you go back to your very first line. So you let x be what? You let x equals to 1 times secant theta, right? So x is equals to 1 times secant theta. Then secant theta is equals to x divided by 1. And then 1 over cosine, that is secant, right? And then equals to x divided by 1. And then you take the reciprocal on both sides. Cosine theta is equals to 1 divided by x. According to right triangle trigonometry, SOHCAHTOA, CAH, the top is adjacent, the bottom is hypotenuse. So this is x, and then the adjacent is 1. And then what about the other piece? So for the other piece, let's change to another color. So the other piece, I can do a quick Pythagorean theorem. A squared plus b squared equals to c squared, right? Then b squared is equals to c squared minus a squared. So go back to the green triangle, that is equals to c squared, which is x squared, minus a squared, which is 1 squared. And then you have sine, right? So your sine of theta, that is equals to SOHCAHTOA, SOH, opposite divided by opposite divided by hypotenuse. So opposite is the square root, and then hypotenuse is x. So overall, you have back to the problem. So we have 1 divided by sine, right? So that will be the square root divided by x plus c. That means it's just a simple reciprocal. So you have negative x divided by the square root and then plus c. Okay, so that is the end of this problem. If you think I picked the best problem for discussion, my explanation is clear, give me a like, let me know in the comment below, share the video for me please. I really want more people get to know the assistance of this channel. Subscribe to my channel if you are new to the channel. See you all in the next integral. Signing out for now.